Welcome to AP Physics. This is Mr. Smith, and we're looking at how we're going to be using these videos for this class and a short introduction to displacement. So if you're using these videos, what I want to make sure you're doing is you're taking notes. You're not just watching this as you're doing something else. Make sure you're taking the information from the screen and putting it down somewhere else. Sometimes just the process of writing it down helps, but a lot of people it'll be easier if you can go back to the information. Make sure you're not doing any other distractions while this is going on. TV, YouTube, siblings, whatever it is that can be a distraction for you, make sure you're focusing on the videos and the information in them. Make sure you're actually becoming an active participant. Don't just sit and listen to what I'm doing, kind of zone out and move on. It's part of the distraction, but this is the active part of it. You need to be actively listening, actively taking notes, actively looking at the textbook and moving on from there. When there are practice problems, don't just watch me do it. Do your best to solve along with it. If you get stuck, kind of move along from there. Then if you get stuck, rewatch it, figure out, if you're able to understand the material a little bit better through multiple viewings. This is something, instead of just asking someone to repeat something and they get frustrated because they think you weren't listening the first time, sometimes you need to hear it more than once to understand what's going on. So I would recommend that you rewatch any sections that you have trouble with. And then finally, bring questions to me, either through email, through Google Classroom, or just in class. The beginning or the end of class is usually a good time to do that, or as I'm coming around to check off homework. These are all good times to kind of go through and understand what's happening. All right, with that out of the way, let's get started. So the idea, one of the main concepts that you need to understand in physics is the idea of a vector. Vectors in physics are used almost constantly. The first one we're going to deal with is what we call position. When you represent an arrow, so those of you who have watched Despicable Me multiple times, you'll know the villain vector. It's represented by an arrow, and the two properties that it has are both the magnitude, and depending on which type of vector it is, this magnitude will mean something different, but when we're representing it, it'll just be the length of the arrow, and then the direction. That can either be an angle relative to an axis or north, south, east, west. There are a lot of different ways to represent the direction as well. So when we talk about position, what we really mean is where something is related to kind of a commonly defined origin, a zero. So there's usually that original piece of information of how far something is away and what direction from a given spot. So it includes the distance, how many meters, and the direction. When we're dealing with one-dimensional motion, a lot of times the direction can just be a positive or a negative. In general, positive would be to the right, negative would be to the left, or we could have positive being up, negative being down, and you can define that any way that's useful. You could do north, south, east, west, or at any angle along there. And a lot of times when you're dealing with angles, you look at the angle relative to the positive x direction. But that's not necessarily the only way to do it. Like compass headings always go from north, and instead of going counterclockwise, they travel clockwise. But when we're talking about position, we have to communicate what symbols we're trying to use. In the textbook, they use S. CP Physics uses D. A lot of textbooks use X. I think the AP Physics uses X. But we're going to use a slight different version there. We're going to use R. R meaning it's the position that of an object is relative to an origin. So it's like the radius of a circle, but we're measuring from the center. So we'll use R that'll have components in the X and Y or Z, or even if it's just horizontal. So if it's in 2 dimensions, the magnitude of R is going to be like it's a triangle. You have square root of x squared plus y squared, and then the angle will be related to y and x. So just imagine here you had something that was 2 meters to the right, 3 meters up. The overall distance would be the square root of 3 squared plus 2 squared, or the square root of 13, which everyone knows off the top of their head is 3. But when we're talking about displacement, that's when we actually start looking at how things change. It's the difference in 2 points of position. The symbol we use for displacement is delta r, so the Greek letter delta, meaning change. So it's the displacement between the initial position and final position. So you subtract final minus initial, and that will tell you how far something has moved. So in general, the way we would write that as delta r, or displacement, is equal to the final position minus the initial position. The subscript 0 is usually used to be the initial position, where it starts out. And that's the information we'll need for this first segment on displacement. Thanks for watching.